So I thought I was recording the video last time, but I did not. I think the share was not properly done. So the screen went blank. So I'm repeating it again. Um, so uh, in the last video, what we had done is we had looked into integer, I think. So in case if you want to go ahead with the float, I can, sorry, I can go ahead with any decimal value. If I take integer y, then I can take some integer value there. Boolean will be either true or false. False will be indicated as 0. True means it is going to give you as 1. Now, I wanted to take a long integer value to store a large number because long capacity has 8 bytes in C++, which means 2 raised to 0 to 2 raised to 63. All the bits, if it is turned on 1, then what is the decimal conversion you will get? That is the maximum positive value that you can store. So now, when we print this, am I sharing it right? Yes. Then if you run this program, you're going to get, if you notice, the values are properly done. Flag is 0, even though you have given it as false. If you make it as true, it will become 1. So internally, it is going to compute false as 0 and true as 1. Okay. So the next one, if I want to go ahead with the operators, okay, I'm going to make this as integer first. If you take an int and then take the variables as a, b, sum, difference, quotient, and so on, ask the user to enter the values. Now, in the same line, if you want to enter two values, then I can take cin operator, but only thing is I have to give a space in between these two variables. Then I have declared all these variables. I'm going to add with plus symbol, subtract, difference, multiply, that is asterisk symbol, quotient will be slash. Now, in this, I'm going to just make it as a modulus b. That means if I have 11 and 2, 11 when you divide by 2, your remainder will be 1. Okay, I'm not talking about the quotient, remainder. That is here. You're going to print all these things. If you run this, if I give 11 and 2, you're going to get the value. But if you notice the quotient, it's going to give you 5, correct? So this should have been 5.5. Why it is giving us 5? Because we have integer a and integer b. So integer division will not give you a floating point. It is going to give you a integer value itself because you have taken the quotient also as an integer. Okay. And these two values are also integers. So here I'm going to make it as float. Now, when I make it as float, right, what happens? The remainder will only operate on integer. So if I run this, you're going to get an error. So what I'll do, I will convert the floating variable to integer by typecasting. That means if I have 4.5, I want only the integer part. So it will take 4. Even here, I'm going to take it as int. Now, when you're going to run this, if I'm going to give 11 to, you're going to get 5.5 because decimal float is the data type for A and B. And also quotient, you have taken it as float. So when you divide two floating variable, you'll get a floating value as well. Remainder is 1 because I have converted both the things into integer. Even though it is 11.2 or 2 point something, it is going to give you it as a integer because we have typecasted it. Now, how did we typecast it? So here we are going to give it as, let us say, int x is equal to, no, I'll take a float variable. Float x is equal to 77.8. Okay, now I'm taking int y is equal to int of x. That means I'm going to store only the integer part. What is the integer part? Only 77. That is the integer part. Okay. So here, if I'm going to give C out x value, you run this, you're going to get y is equal to 77. That means you have typecasted it. You have neglected the decimal and only taken the integer part and stored it in y. Okay, this is called as typecasting from one type to another. Now we have Mhm. And logical operators, that is and not. What does and do? If there is condition 1 and condition 2, if the first condition is true, second condition is also true, then the output will be true. If the first condition is true and the second is false, any one of these condition is false, your output will be false. In which gate? In and gate. Now what might be the condition? Is x greater than y? Is x greater than z as well? If both the condition are true, then x is greater probably. In a similar way, for OR gate, in OR gate, the condition is any one of the condition should be true. Either condition 1 should be true or condition 2 should be true. Any one, if it is true, then the output is true. But if both are false, then the output will be false. Then there is not gate. If the condition has been given as true, not of true is equal to false. If the condition is false, not of false is equal to true. These are the logical operators. Okay. Where do we use it? We use it in something called as conditional statement or decision making statement, which we call it as if, else if, and all those stuff. We'll be studying about this in the next video.